I hope you've done the second part of 5 and 6. I've got the answers for 5 up here on the board. I'm just going to talk through them very quickly and then we'll work through 6 in a little bit more detail. So for the domain, the rule is the bottom can't be 0, so I can see x can't be 4. So my domain is negative infinity to 4, union 4 to infinity. For the y-intercept, that means my x value is going to be 0, and when I plug in 0 for x, I get out 0 for y. Now, that right there tells me that the origin is also a y-intercept, an x-intercept. By definition, an x-intercept is going to be a point where the y value is 0. I do want to check, because functions can have more than one x-intercept, so I want to do a quick check. Is there anything else that would make the top 0 and not make the bottom 0? And the answer is no. 3x is only going to be 0 if x is 0, so the origin is both my x and y intercept. All right, for question number 6. Again, we've got a fraction, and the rule is that the denominator can't be 0. So 3 plus the absolute value of x minus 1 cannot equal 0. And when you're working with absolute value equations, and this is just a sort of non-equation, okay, you always want to isolate the absolute value first. So I'm going to subtract the 3 over and say the absolute value of x minus 1 can't equal negative 3. And okay, it isn't. That's always true, because absolute value is never a negative number. So this doesn't actually put any restrictions on my domain. So my domain for question 6 is going to be negative infinity to infinity. All right, that's important. When you're working with absolute values, you don't just work through until you get an answer. You have to, once you've isolated the absolute value, take a look. If that's negative, there's not going to be any value of x that could make that equal a negative number. So if it was an equal sign, there would be no solution. If it's a not equal sign, it's always true. All right, then finding the y-intercept. So that's going to mean that x is equal to 0. And I can see if I plug in 0, I'm going to get 0 over, it'll be over 3 plus 1. Let's actually work that out. F of 0 is going to be 2 times my input over 3 plus the absolute value of my input, minus 1. My input is just 0. I'm going to plug that in. So I get 0 on top. It really doesn't matter what I get on bottom as long as I don't get 0 on the bottom. Okay. But if I take a look, this is going to be 3 plus the absolute value of negative 1. That's 0 over 3 plus 1. That's 0 over 4, which is 0. As long as I get 0 on the top and not 0 on the bottom, it's going to equal 0. All right, and then I can see that's also going to be an x-intercept, because that makes the y value 0. Is there anything else that makes the top 0? And the answer is no. The only thing that would make 2x equal 0 is if x is equal to 0. So the only x-intercept is the origin. All right, that finishes up section 1.3. Now section 1.3 was a big section. We were just introducing relations and functions, but in the process, a lot of issues came up because we had to review a little bit about roots, we had to review a little bit about powers, we had to review a little bit about absolute value. For some of you, you probably felt really great about all the review that we did. You were like, I remember this, or you didn't remember it. And then as I did the examples, you're like, oh yeah, okay, that's coming back to me. That's fine. Others of you, you might have said, you know what? I feel a little bit shaky with those absolute values, or I feel a little bit nervous about working with roots. If that's the case, we started here in chapter 1. There's a chapter R, which is a review chapter. Okay. And that goes over a lot of the things. Now, I'm not spending class time, which is these videos, going over chapter R, because not everybody needs that content. But you may find that you have some particular areas that you want to brush up on a little bit, in which case I'd say look at that section of the review chapter. And that's the sort of thing I'm more than happy to work with you on. I don't want to make the entire class work through that entire chapter because not everybody needs it, but I'm happy to answer questions about it, and I'm happy to spend time in office hours or by appointment going over those things. So if as we were reviewing any of the algebra that just happened to show up in the functions and relations that we were working with, and you said, ooh, I need to brush up on that, this is now an invitation to come into office hours or make an appointment with me so that we can brush up on that together.